Hey everyone, welcome back to the Data Science Stories for the Built Environment. In this video, I'm going to tell you a story about two of our characters and their role in the design phase of buildings. Do you remember Phil and Jane? They both found jobs in the same design firm, one as an architect and the other as an engineer. Let's jump into their stories to see the problems each job is facing and subsequently how programming and data science is used to improve their situation. Let's start with the architects. It was Phil's first day at work, and he was invited to join the architects at their weekly meeting. His supervisor caught him up with their current projects and explained more about the software that they always use for design of buildings. Rhinoceros, also known as Rhino, is a 3D CAD software that many architects use for modeling their ideas. It is often used for creating, analyzing, editing, and rendering models they have drawn up. However, the whole process of creating models on Rhino is often very manual and time-consuming. Their team of architects has spent day and night on the software and has realized that they were limited to making only 3 different blueprints. Phil realizes how similar this problem was to one of the case studies he encountered and lectured, and suggests the use of Grasshopper. Grasshopper is a visual programming tool that is closely integrated into Rhino 3D. It uses a node-based editor for the user to incorporate various boundary conditions for parametric analysis. Through the use of generative algorithms, it creates numerous designs based on the parametric details and provides a variety of models for the design team to choose from. Grasshopper seemed to be able to help them with their problem. Phil then proceeded to demonstrate to his supervisor how Grasshopper and programming can be used with the current project parametric details. In no time, many design options were being generated automatically, giving them numerous choices to give to their clients to choose from. Mission accomplished. Moving on to how programming can help improve the workflow of an engineer, we have Jane, who graduated with a degree of engineering. In the engineering department of the design firm, her supervisor shows her what the engineers in the firm are currently handling. Designs have been generated by the architects that get sent over to the engineers. The engineers draw up energy models that can aid architects in decision-making and cost estimation for future use. However, since the architects have been able to create so many different designs, the engineers can't keep up and are slow in model development. Jane remembers some content from her lectures about a plugin for Rhino and explained more about it to her supervisor. Jane described the use of the Ladybug tools, which are plugins that can be integrated into Rhino. These tools include the Butterfly, Dragonfly, and Honeybee tools. Honeybee, for example, is an open-source Python library to create, run, and visualize the results of daylight and energy analysis. Honeybee uses Python-based models to calculate heating and cooling energy usage and advanced solar radiation, generate colorized zones with energy results, and run energy simulations. This platform automates the whole process of running energy simulations for the engineers, and they can now keep up with the rapid production of design options from the architects. Jane used her programming skills to show how the energy simulation process can be automated. Once again, mission accomplished. Both Phil and Jane have managed to apply what they have learned about programming and data science into the design phase of buildings. Stay tuned for more exciting episodes of how the other characters can do the same thing.